Presentation, inspiration, and motivation have always played key role in the success of any venture. Hello and good afternoon, everyone. I Smriti Darjee, bearing roll number 20NS0323 from Sikkim Government College, Namchi, South Sikkim, affiliated to Sikkim University. This presentation is part of our seasonal B assignment for paper 7, which carries 25 marks. I express my sincere thanks to our Department of Physics for giving me this topic as an assignment, as well as especially thanks to my guide Dr. C.P. Khatiwara, whose valuable guide and kind supervision support me or encourage me throughout this assignment. So my presentation is on the topic transmission electron microscope and high resolution transmission electron microscope, that is TEM and HRTEM. So let us understand what is TEM first. Transmission electron microscope or TEM is a very important tool in nanotechnology in which electrons are made to fall on the surface. So it is part of nanotechnology. TEM is one of the most important device under nanotechnology. It contributes to make nanotechnology as very vast subject. The electron interact with matter and got transmitted and state of fluorescent screen and produces high resolution sample images. So in this we will follow electron in sample surface whose electron interact with matter and transmitted through it and strike a fluorescent screen which produce sample image with high resolution. It is invented by German physicist Ernst Ruther, for which he got Nobel Prize in 1986. So, what is principle of TEM now? TEM works on basis principle, has light microscope but uses electron beam instead of light beam to produce an image. As we know that de Broglie wavelength electron is much smaller than that of photon. So TEM is capable of producing high resolution image of sample TEM. TEM can reveal finest detail of internal structure of sample. So what are the instruments used in TEM? Let us understand. There are four instruments, that is main instrument. These are the main instrument which is used in TEM. That is, first we will keep electron gun which is in V shape tungsten, and secondly we will put electromagnetic has condenser lens. Third, we will put vacuum system. Fourth, we will put specimen stage. Let us know how we will put this in a sequence manner. So this is electron gun on top of the condenser lens. This is condenser lens, and this is here which is on pink. It is a sample, and below that there is objective lens and projection lens which is both is electromagnetic lens, that is condenser lens, and the image is formed in fluorescent screen, that is on the bottom of it. So let us understand this instrument here from the first. Electron gun filament which produce stable beam of electron using thermonic emission. Using thermonic emission, it generates electron which is also called the source. As electron gun which is on V shaped tungsten, it produces electron. And second instrument is electromagnetic, has condenser lens. The focusing and the intensity of element beam is controlled by electromagnetic or condenser lens system placed between the electron gun of a specimen. It consists of copper coil. Current is made to pass through coil copper, which creates magnetic field. So this is nothing but just a copper coil in which current is regularly flowing through it, which generates magnetic field between it. Vacuum system. Vacuum pump are used to evacuate the TEM to low pressure up to 10 raised to power 4 Pascal, that is as a unit of pressure. Evacuation helps prevent generation of ARC. It helps, this vacuum system helps the, we know that electron is very reactive substance, right? It is negative in nature and it is very reactive to the air, the moist. So that's why we kept vacuum pump as a protector from reaction of electron. And the specimen of the stage, so we will learn here how this specimen should like what how it can resolve this. It is used to hold a specimen under investigation. It is form of mesh, that is like which I have shown in picture. This, it is like this mesh is like this, having diameter of 25 millimeter, that is a wide spread of design of specimen stage exists depending on take of sample under investigation. In a specimen in TEM are usually 100 nanometer thick, so it is very small small thing. Her specimen is it is 100 nanometer thick, which is not visible by our eyes as well. So that's why we use TEM to resolve this. And the viewing screen, we know that it is a fluorescent screen where the image is produced, which is located at base of microscope column, which produce light. When transmitted, electron strike it to form 2D image of sample. So I have shown this image earlier. So how does it works? So it simple, use a high voltage electron beam to create an image. An electron gun emit electron that travel through the vacuum and column of microscope. Instead of glass lenses following light as light microscope, the TEM uses electromagnetic lenses to form electron into a thin beam. The electron beam then passes through the specimen under investigation. Some electron get scattered by other electron get transmitted through the sample. At the bottom of microscope, the transmitted electron hit a fluorescent screen which produces image of a specimen. Thus, the image can be directly studied by computer or topographical image using camera. So the working is like this. When we use high voltage of electron beam, it tends to create image on fluorescent screen as a final result. And in a systematic way, when an electron gun emits the electron, it travels through the vacuum column of microscope. So when it interact with lens, the most of electron get transmitted through it, penetrate through it from light microscope, light microscope, where light penetrate through the lenses, and when the electron beam is passes through the sample under investigation, some electron get scattered and get transmitted through the sample. At the bottom of microscope, transmitted electron hit the fluorescent screen, which provide image of specimen to the in the fluorescent screen. So what is the uses of this TEM? So some of the uses are it can treat the cancer. It can it is used to study the tumor cell ultrastructure, to produce ultrastructure, to examine biological sample, virology. Study of a virus is called virology. We can study virus through it. Uses in medical sciences, it is mostly uses in medical sciences like by bacteria, protozoa. We can study it helps to study those organisms. And it is also, as I have already said, that it is used in nanotechnology. It plays a vital role in nanotechnology. So let us understand the advantages of TEM. What are the advantages? What is the merit of TEM? The first number is high quality image can be obtained with TEM. We know that nanoparticles are, it gives the high quality image of nanoparticles. TEM have various application, has high spatial resolution in different fields such as scientific, educational and industrial fields. TEM can provide information about surface feature, shape and size and structure. It can provide information about virus, bacteria, and many other that which is not seen by our naked eyes. It gives shape, size and physical structure of that organism. Let us understand what is disadvantage of it. The instruments that are very large and expensive. It is very expensive, and it is large as well. TM requires special housing and maintenance because they are sensitive to mechanical vibration, fluctuation of electromagnetic field and vibration of cooling water. So it needs a special housing and maintenance. It should kept separated. It should kept in separate way. Special training is needed for to operate and data analysis. To operate work in it, we have to take a special training. So it may be a little bit costly for us to bear all those things. So I'm taking you to another topic of my presentation, that is HRTEM. Let us understand what is HRTEM. It is as simple as that of TEM. So let us here I go. High resolution TEM is ultimate tool in imaging defect. In favorable classes, it shows directly a two-dimensional projection of crystal with defect and all. Of course, this only makes sense if the two-dimensional projection is down some low index direction, so atoms are exactly on top of each other. So this is the figure of HRTEM. Optical axis lattice images is produced here on the bottom of it. Diffractive this is the way the way the optical it diffract the specimen is diffract on it. Working principle of HRTEM. So this basic involves in the formation in both microscope. TEM and HRTEM is similar. However, HRTEM provide high resolution images at atomic scale level, uses both scattered and transmitted beam to create an interference. It is phase contact image and can be small as unit of crystal. In this case, the outgoing modulated electron wave are very low angle interfere with itself during propagation through objective lenses. All electron emerging from a specimen are combined at point in image. Application of HRTEM. What are the daily uses of HRTEM? Enable atomic column to be resolved in mode inorganic material. Determine the atomic scale microstructure of lattice defect and order in homogeneities. Determine the characteristic of jet and O nanotube. So what are the similarities between TEM and HRTEM? Though this both are microscope which resolutes specimen, this is equally like it is kind of similar to each other. So let us understand what is the similarities of it. High resolution transmission electron microscope. HRTEM is identical to transmission electron microscope imaging except that magnification used are high enough to easily see the lattice spacing of inorganic substances. So from HRTEM and TEM we can see the spacing of lattice inside a solid cube or in a inorganic substances. Difference in TEM and HRTEM. So what is the difference? We have already read the similarities between it, so we will know what is the differences. TEM uses the interaction of energetic electron through electron gun or tungsten. So I have already dictated you or understand make you understand in previous slide that TEM uses the electron gun, and in HRTEM uses transmitted and the scattered beam to create a interference images. It uses the both beams transmitted and scattered beam to create an interference of image. Thank you for watching video.